Today we are going to inverter and its classifications. In previous classes we have discussed about converters and choppers and control modes of choppers and application of converters, different types of conversion, and we have different types of load you have to connect it to the converters. You have to learn. So this is the one of the converter. This is the one of the converter. That is the inverter. That is the inverters and its classification. So in last class we have discussed about classification of chopper and operation of chopper in all four coordinates, and operation of chopper in all four coordinates, and types of choppers, the classification of choppers. In last class we have to discuss, but here today classes we have discussed about the concept of inverter and classification of inverters. Before going to our topic, what is the inverters, what is the converters, what is the choppers, what is the rectifiers, what is the control rectifiers. Once again let us discuss here the converters. The so many types of converters in there is there in power electronics. So many types of converters in power electronics converter. So the first type is nothing but the rectified. First types of converter is nothing but rectified. Rectifier remains two types: rectifiers and uncontrolled rectifiers and controlled rectifier. Uncontrolled rectifier and controlled rectifier. The uncontrolled rectifier is obtained by the using of diode. The rectifier is nothing but which convert from AC to DC, AC power into DC power. The uncontrolled rectifier is obtained by using the diode. And control rectifier is nothing but which convert the AC power into DC power with the controllable output voltage. Output voltage is the controllable. In control output voltage, we have to use the power semiconductor device act as a thyristor. Power semiconductor devices have to use the thyristors. So here, and chopper. The chopper is nothing but which convert from fixed DC into variable DC. Fixed DC voltage into variable DC voltage, or fixed DC power into variable DC power, variable DC power. So that is called as the chopper. For the low and medium application, we have to use the transistors. For high applications, we have to use the thyristor. So here next classification is nothing but inverter. The next classification is nothing but inverter. So the inverter is a device which convert DC power into AC power at desired output voltage and frequency is called as inverter. A device which convert DC power into AC power at desired output voltage and frequency. Is called as inverter. The inverter are mainly available from the few watts to 1000 watts of kilowatts, and operate at high frequency from 50 Hz to hundreds of kilohertz. This is the availability of inverter. The inverters are mainly available from the few watts to thousands of kilowatts. So it operate at is a frequency operated at frequency from 50 hertz to hundreds of kilohertz, 50 hertz to hundreds of kilohertz. So this is called as the inverters and availability of inverter, definition of inverters and availability of inverters, which convert from the DC power into AC power, DC power into AC power. Desired output voltage and frequency is called as inverter. That means we have to convert from here the DC power into AC power. If there is no availability of during the interruption of AC voltage, how it can be possible for the AC voltage, AC load is operating by the using of inverter, inverters. By how to use the inverters? The inverter is the device that consists of DC source and inverter circuits and last load. We have to connect to the load. So this is the process of inverters. Next, the requirement of inverters. What are the requirement of inverter? For the conversion of DC power into AC power, some the requirement is there, some availability of requirement is there. That is the able to operate for the inductive loads such as motors and fans, like this. Her ability to work under the no load condition or load is disconnected. For the requirement of inverter, ability to operate for the inductive load such as motors and fans, and ability to work under no load condition and load conditions. So here, and provision for overcurrent protection, and it should not operate beyond its rating, So this is the requirement of inverters. Next, classification. The classification of inverters. Before going to classification, let us discuss about the inverter. A power inverter is a power electronics device or circuitry that change direct current to alternate current. It is also called as inverter definition. The change the DC current into AC current, the DC current into alternating current or AC current. So it is also called as inverter. This is also called as inverters. The input voltage and output voltage and frequency and overall power handling is depend upon the design of specified device or circuitry. The output voltage and frequency. is depends on the design of the specific device or circuit. It depends upon the circuit and specification of device. The specification means the output, the voltage rating, current rating, power rating, and voltage drop rating, and device handling capacity, temperature rating. All this called as the device specification of device, specification of design of specification of device and circuitry. An inverter is used to produce an uninterrupted 220 volts AC or 110 volts AC depend on the line voltage of the particular country. The supply to device connected as the load at the output socket. A inverter is used to produce an unlimited 220 volts or 110 volts AC, depend upon the line voltage of the particular country. The supply to the device as load at output socket. The producing unlimited voltage, that is the 230 volts or 120 volts. If we have to produce the 230 volts, 220 volts or 110 volts we have to producing, then which is the directly is connected to the load at the output socket. It is connected with the output socket. So this is the meaning of this slide. Then the inverter gives the constant AC voltage at its output socket. The inverter gives output AC voltage at its output socket when the AC mains power supply is not available. If the AC voltage is not available during the interruption of AC voltage, then we have to obtain the power supply from the inverters. So the inverter gives the constant AC voltage. AC voltage at output socket when AC power supply is unavailable. If the AC power supply is unavailable, that means the AC power supply is interrupted. At the situation of AC power supply is interrupted, then we have to obtain from the output socket of the inverter. So this is the different types of inverter. This is the figures of different types of inverters and different types. So all this called are the different types. This is the figure of inverter. This is the figures of inverters. These are inverter circuits. This is the inverter circuits. Here in this circuits, we have connected with the battery. We have to connected, and that is the inverter circuit. This is the inverter circuit and the motherboard, IC, etc. And it is the inverter battery supply is given to the inverter circuit. Then from the inverter we have to obtain the output terminal. And at the output terminal at 220 volts AC, at the output terminal we have connected to the load. That is, here we have to bulb is connected here. So this is the inverter circuits. The DC power supply, we have to convert from the DC power into AC power, means the DC source is nothing but here battery. And convert DC power into AC power. How to convert DC power into AC power? By the inverter. All is called, middle one is called as the inverter circuit. And last one is called as the load. So this is the inverter circuit, and this is the different types of inverter. This is the basic circuit. This is the basic inverter circuits. This is the different types of inverter. Different types of specification of different specification of device, and the different voltage rating. Different voltage rating of inverter. This is about the inverters. Next, classification of inverter. Classification of inverter. The first classification is nothing but based on the number of phases. number of phases. Based on the number of phases. The first classification is based on number of phases. Based on the number of phases, the two types is there. That is a single phase inverter and a three phase inverter. Single phase inverter and a three phase inverter. Based on the number of phases, first one is nothing but single phase inverter. Second one is three phase inverters. Next classification is nothing but based on the nature on driving DC source. Nature on the driving DC source. The input side we have to connect it the DC source. It is convert from the DC power into AC power. That is the definition of inverter. That is the definition of inverter. So here the main source is nothing but DC. Here the main source is nothing but DC. The inverter of main source is nothing but DC. So the based on the nature of driving of DC source, the based on the nature of source, the remains two types is there. That is the voltage source inverter and current source inverter. Voltage source inverter and current source inverter. That is the VSI and CSI. Here the source act as a voltage. First one. And second one nothing but here source act as a current. So voltage source inverter and current source inverters. Next classification of inverter. Next classification of inverter is nothing but the based on the types of commutation in the thyristor. In the DC machine, the commutation is nothing but the transfer of DC supply. That is called as the commutation. But in thyristor circuit, in power electronic circuit and the thyristor circuit or power electronic circuits, the commutation is nothing but it act as a off state of thyristor. It is after the off state of thyristor or turn off of thyristors. So the based on the types of commutation in the inverter, based on the types of commutation in the thyristor, the four types of thyristor is there. The first one is nothing but four types of inverters is there. Based on the types of commutation in thyristor, the four types of inverters is there. The first one is nothing but line and natural commutation inverter. And second one is nothing but forced commutation. And third one auxiliary commutation of inverter. And fourth one is complementary commutation of inverter. Complementary commutation. First one nothing but natural commutation or line commutation, forced commutation, auxiliary commutation, complementary commutation of inverter. This is the types of based on the types of commutation. These are the classification of inverter. This is another types of classification. Next, based on the types of output voltage. These remains three types is there. That is the sine wave, square wave, quasi square wave. So based on the output voltage, the wave we have to obtain in the shape of first shape is nothing but sine wave. And sine wave already you know that sine waveform is the wave shape is the sinusoidal. So this is the one of the types of output voltage you have to obtain. This is the one of the types of output voltage we have obtained. That is the shape of sine wave, sinusoidal wave shape. Output voltage obtained. These types of output voltage how to obtain by using these types of inverter. And square wave output voltage. The square shape, the output voltage in the form of square shape. square shape. So this is called as the square wave output voltage. So these types of output, these types of inverter, by using of these types of inverter, we have to obtain the square wave output voltage. These types of inverter, by using these types of inverter, we have to obtain the square wave shape, the square wave shape output voltage. Next types, next types, the quasi square wave, the quasi square wave, the quasi square wave, the quasi square wave shape. By using these types of inverter, we have to obtain the quasi square wave output voltage, the quasi square wave output voltage. So this is the other types of inverter. This is the other types of inverters. Next classification. The next classification is nothing but based on the types of connection. The circuit connection. The types of circuit connection. Here the first types of circuit connection nothing but series inverter. The inverter series inverters. Next types is nothing but parallel inverters. Next type is nothing but parallel inverters. Next type is nothing but bridge inverter. What is the series inverter? What is the parallel inverter? What is the bridge inverter? What is the series inverter means? Here the thyristors in this circuit, the thyristors are connected in the series. So that is called as the series inverter. These are based on the types of connection, the circuit connection, based on the types of circuit connection. That is the series inverter means. Here in this circuit, the thyristors are connected in the series. With the line commuting line filters, capacity filters like this, and parallel inverter. Here power semiconductor device is connected in parallel in this inverter. In these types of inverter, the power semiconductor device is connected in parallel. That is called a parallel inverter. Next, the bridge inverter. The bridge inverter means here the circuit is connected in the form of bridge. So that is called as the bridge inverters. So this is the based on the types of connection. Next classification, based on the types of the circuit. The first type is nothing but based on the types of circuit. The first types of inverter is nothing but pulse width modulation inverter. And second one nothing but the resonant inverters. The pulse width modulation techniques. Means here we have to use the pulse. By using the pulse, the different harmonics is produced in the output side. By using the pulse width modulation, we have to width of the pulse is changing. Then we have to obtain the output voltage is the smooth and the quality output voltage we have to obtain. Here in this types of inverter, filter circuit is installed, and to reduce and to remove the harmonic. Different types of harmonics is produced on output side in this types of inverter to produce the output voltage, and different harmonics produce. Harmonic means disturbance and distortion. So how can it will be removed? By using the pulse width modulation technique. That this technique is nothing but by the using of width of the change of the pulse, by using the width of the pulse, we have to change the output voltage, and we have to obtain the quality output voltage. You have to obtain the quality output voltage. So this is called as the, this is about the pulse width modulation. Pulse width modulation we have to learn clearly in the next topics, coming topic or next topic, and in higher education, that is the BTech level. In our syllabus also introduce about pulse width modulation techniques. Next, the resonant inverter. Next, the resonant inverter. The resonant circuit is installed in these types of inverter. The resonant circuit is installed in the steps of inverters. So that is called as the resonant inverter. That is called as the resonant inverter. Resonant inverters. Next, based on the next classification. The next classification is nothing but the based on the circuit configuration. Next classification is nothing but based on the circuit configuration. Based on the circuit configuration. The based on the circuit configuration remains the two types is there. Based on the circuit configuration remains two types is there. That is the half bridge inverter. Next one is nothing but full bridge inverter. Half bridge inverter and full bridge inverter. Half bridge and full bridge inverters. So half bridge means here the circuit is the half bridge configuration, and full bridge means here circuit is a full bridge configuration. So this is the classification. This is the classification. This is the classification of inverter. And next classification is the main classification of inverter. In those types of classification, the main classification of inverter is nothing but voltage source inverter and current source inverter. Voltage source inverter and current source inverter. Here the source act as a voltage. That is called as the voltage source inverter. That is the VSI. The main classification of inverter is nothing but voltage source and current source inverter. These types of inverter we have to introduce in our syllabus. So the voltage source inverter, that is the VSI. It is also called as VSI. Here the source act as a voltage. That is called as the voltage source inverter. The voltage source inverter is nothing but it is ones in which the DC source has small or negligible impedance, or it has shift DC voltage source at its input terminal. What is the meaning of this word? Here we have to clearly learn here. So it is a one in which DC source has small or negligible impedance. The source of DC here in these types of inverter, the source of DC, it has the small and negligible impedance. And it shifts the DC voltage source at input terminal. Here the input voltage is given to the inverter. So here the voltage supply is given, that is the voltage supply given by using the DC source, and this DC source has the small impedance, the small or negligible impedance, and it shift the DC voltage source at the input terminal. DC source is shifted, or DC voltage is the shifted. So this is called as the VSI. This is called as the voltage source inverter. The voltage source inverter, input terminal, the input DC voltage is given to the inverter. The DC input voltage is given to the inverter. This source has the small or negligible impedance, or it has shift DC voltage source at input terminal. So this is about the VSI. Next classification is nothing but current source inverter, CSI. Next classification is nothing but current source inverter, that is the CSI. It is feed with the current source inverter. It is feed with adjustable current from DC source of high impedance. It is at form of from the DC current source. So it is a feed with the adjustable current. From the DC source of high impedance. In these types of inverter, in these types of source of inverter, it has the high impedance. In voltage source, it has the small or negligible impedance, but it has the high impedance. So it has the high impedance. It feed the adjustable current. From the DC source of high impedance. Is at from DC source current. So it is called as the current source inverter. The current source inverter has high impedance. So it is a feed. Here it feed the DC current. From the DC source with high impedance. So this is called as the CSI. Current source inverter. In voltage source inverter has the small impedance or negligible impedance. In current source inverter, it has high impedance. Then it feed the DC current from the DC source. So this is about the voltage source inverter and current source inverter. In voltage source inverter, source act as a voltage. In current source inverter, the source is act as a current. So this is about the VSI and CSI. Next application of inverter. This is the another small subtopic of inverter. The application of inverters. The application of inverter is nothing but it is the used in variable speed AC motor drives. The inverter circuit is connected with the AC motor drive, variable speed AC motor drives. We have to connect it to this inverter circuits. So here this types of load, the inverter is feed AC voltage and AC current feed to these types of load, or AC power is feed to these types of load. Next, the inverter is used in high voltage DC transmission system. The inverter is used in high voltage DC transmission system, HVDC system. It is used in HVDC system. The inverter is used in HVDC system, high voltage DC transmission system. You have to use using of inverter. Next, UPS. The inverter is used in UPS, the uninterrupted power supply. The UPS is nothing but uninterrupted power supply. Here the power interruption is there is no power interruption. So here also we have to use the by using of inverter. The inverter circuit is, the UPS is made up of with inverter. The basic the UPS circuit is made up of with inverters in UPS. So the UPS is the two types is there. The UPS is the two types. That is the online preferred UPS, offline preferred UPS. Online preferred UPS, offline preferred UPS. The online preferred UPS means the during the power supply is available. During the power supply is available. During the power supply is available. The inverter of battery, the inverter circuit of battery is charging. The inverter circuit of battery is the charging. And offline preferred of UPS, the offline preferred of UPS means here there is no power supply is available, there is no AC supply is available, and the AC supply is feed to the load, AC load, feed to the AC load by using the inverter. Here source is the battery, here source is the battery, here source is the battery. So this is the UPS circuit. So the inverter circuit is used in UPS. So the inverter circuit is used in UPS. Next classification is nothing but emergency power supply in domestic lighting applications. Emergency power supply in domestic light appliance. The domestic light appliance means nowadays we have to use it in the house, office, shops, and communication system. Like the commercial purpose or domestic purpose, we have to use. That is the lighting purpose. That is the lighting purpose. When the AC supply is unavailable. When the AC supply is unavailable, and during the interruption of AC supply. During the interruption of AC supply. So we have to use the inverter. We have to use the inverters. Next classification next application nothing but timing device. Next timing device. The timing device circuit also we have to use the inverter. Here in the timing device, during the power supply, AC power supply is interruption. That is the unavailability of AC. So that is the interruption of AC supply. What will happen? The timing device is not working. The timing device is not working. So here the time counting is less, and some businessmen and some workers, it has to need the calculation of time, the timing devices. So in this device we have to connect with the inverter circuit. We have connected with the inverter circuits. So you have to using of in these circuits. So it is the used in timing device. Next class is nothing but the AC power supply for laser circuit. The AC power supply for laser circuits. The power supply to the laser circuits. So it is the used in laser circuits. So these are the application. These are the applications. The 6 types of application is there. They are the application. So here we have discussing about today topic is nothing but definition of inverters. The definition of inverters. That is, definition of inverter is nothing but the inverter which convert DC power into an AC power at desired output voltage and frequency. So that is called as the inverter. That is the definition of inverters. Next, what we have to learn for the high power application, thyristor thyristorized inverter are used. For high power application, thyristorized inverter are used. But for the low and medium power application, the transistorized inverter are used. Low and medium power application, the transistorized inverter are used, and high power application, thyristorized inverter are used. High power application thyristorized inverter are used. Next, the thyristorized inverter is required the forced commutation circuit. The thyristorized inverter are required the forced commutation. Forced commutation is circuit is required. And transistorized inverter can be operated at high fair frequency. The transistorized inverter can operate at higher frequency above 20 kilohertz. Above 20 kilohertz. The transistorized inverter can be operated at higher frequency above 20 kilohertz. And these are the main highlights. These are the highlights of inverter. These are highlights of inverters. These are the highlights of inverters. And here the AC output voltage waveform. The AC output voltage waveform are non-sinusoidal and constant harmonics. The AC output voltage waveform. The AC output voltage waveform are non-sinusoidal and constant harmonic, and it consists of harmonics. Suppose you have to obtain the you have to convert the DC power into AC power. At the output side is the AC. At the output side is the AC. So it consists of some harmonics and non-sinusoidal. Consists of harmonics and non-sinusoidal. So this harmonics and pure sinusoidal waveform obtained by using the some techniques is there. That is the one of the type is called as the pulse width modulation techniques. And we have to introduce the filtering. We have to introduce the filter circuit. We have to introduce the filter circuits. The AC output voltage waveform. The AC output voltage waveform. The inverter is a and we have to learn about the application of inverter. Learn about application of inverter and classification of inverter. Today topic definition and definition of inverter and classification of inverter, definition of inverter and application of inverters. So today topic we have to discussing and some highlights is there. All these points of you have to note down and keep in your mind for the competitive exam purpose. Now some quiz question is there. Some quiz questions. Inverter is a device. The inverter is a device which convert. The inverter is a device which convert. Option A, AC supply to DC supply. DC supply to AC supply. Option C is nothing but fixed DC to variable DC. Option D is nothing but fixed AC to variable AC. Which option is correct? The inverter is a device which convert from DC supply to AC supply. This is the main definition of inverter. So the option B is correct. Next, different size of load we have to use the inverter. So what is size inverter should you buy? For the device, and this is watts. For the laptop, 90 watts. For the light bulb or light, 100 watts. LCD television, LCD TV, 250 watts. And printer is the 50 watts. This is the rating. Different size. This is a different size of inverter, then we have to depend upon this rating, we have to buying the inverter. These are by using of this wattage for the different types of load. Then we have to calculating total load and calculating the total wattage. Then we have to buy the inverter. Depend upon the calculation and depend upon the rating. Then we have to calculate the inverter. Calculate the inverters. Next, some frequently asked question. The first question is nothing but what is an inverter? First question is nothing but what is the inverter? What is the inverter? That is the definition of inverter. That's a definition of inverters. Next question is nothing but classification the types of inverter. Classification of types of inverter. Different types of classification is there. Different types of classification is there. That is the classification of types of inverters. Next types of inverter is nothing but state the application of inverter. State the application of inverter. State the application of inverters. So many applications is there. We have to discuss today topic. Discuss in today topic. We have to read that and keep in our mind and explain them. That is the state the application of inverter. That is the state of application of inverter. So these are the some question. This is the questions, frequently asked questions. So these are the many classification we have to learn today, and definition and application. This is a basic circuit diagram. Basic circuit diagram. Basic circuit diagram of inverters. Basic circuit diagram of inverters. And here the applications. Here are the applications. 6 application is there. And some highlight points are introduced. Some highlight points are introduced in summary. These points also note down. These points also we have to note down. So the today topic you have to read well, prepare well, and keep in your mind. All the best. Thank you.